Hi everyone, Happy New Year! I hope you had a wonderful 2016 and look forward to a remarkable 2017. I am Mariam Kaveshgar from Intelligent Transportation System podcast. We have a very interesting program to start the new year. A long-awaited and interesting interview with Professor Brandon Morris from University of Nevada, Las Vegas, and Dr. Mohammad Shirazi from University of Cleveland, conducted by Dr. Ansar Yasar, a professor at Hasselt University. Professor Haluk Eren reviews a book titled Mobile Electric Vehicles Online Charging and Discharging. Let's begin today's episode with the news mini section by yours truly. This is the news mini section for episode 38, January 2017. The first news we have is from NVIDIA, which has introduced its newest model of NVIDIA Drive PX2, the artificial intelligence car computer for self-driving vehicles in different sizes and power consumption levels. The scalable architecture allows one to have a wide range from a 10 watts passively cooled mobile processor to a multi-chip configuration with 2 mobile processors and 2 discrete GPUs delivering 24 trillion deep learning operations per second. Multiple platforms can be used in parallel to enable fully autonomous driving. Use of deep neural networks or DNN for the detection and classification of objects dramatically increases the accuracy of the resulting fused sensor data. Remember the EZ10 in Finland? Well, now it is in Germany too. Since October 2016, the EZ10 driverless shuttle by EasyMile is transferring the employees of Deutsche Bahn along a 1.6 kilometer route at the Schenker site to collect the user feedback and test the vehicle operation and technology under real-life conditions. The same shuttle was in Paris and Dubai. Radar, camera, ultrasonic sensors, and LiDAR are the eyes of the driverless car. However, the latter is quite expensive. LiDAR systems introduced in premium cars are based on mechanical scanning mirrors. They are bulky and expensive. To become a standard feature in all car classes, LiDAR systems need to be semiconductor-based, thus getting more compact, cost-effective, and robust. Microelectronics from Infineon Technologies is a key technology for automated and connected driving. Infineon has acquired 100% of Inolus, a semiconductor company headquartered in Nijmegen, Netherlands. Based on the know-how of Inolus, Infineon will develop chip components for high-performance LiDAR systems. Uber relocated its driverless car fleet from San Francisco to Arizona. Uber launched its second pilot program in San Francisco early December, but the day it launched, a car ran straight through a red light. Uber says it's a human error. It is still not clear the driver drove through the red light or he was not able to interfere in autonomous driving. 2016 was a very happening year for intelligence transportation and driverless cars. Let's hope 2017 will be even more productive. Subscribe to the ITSPodcast. Stay tuned. Now let's listen to Professor Haluk Eren and his book review.
This is the book review section for the present episode of ITSPodcast, reviewed by Dr. Haluk Eren, Firat Universtiy, Turkey. The brief book title is Mobile Electric Vehicles Online Charging and Discharging and consists of 73 pages, written by Miao Wang, Zhang, and Shen. It is produced by Springer in 2016. 5 chapters of the book consist of many ideas and related theories for online charging and discharging of electric vehicles, which refers to coordinated charging for electric vehicles. This scheme provides effective energy utilization, removing grid overload. It discusses discharging the stored energy and loss in EVs to the grid by distributed generators to smooth the voltage and frequency fluctuations. The book elaborates different temporal charging-discharging coordinations of stationary vehicles to keep away from overloading or to regulate the grid. In turn, the grid serving for mobile vehicles on road, spatial coordination copes with EV range problem as arriving at charge station, which maintains the balance between the stored energy and the travel cost. The present book introduces an online charging-discharging strategy provided by spatial and temporal coordination, considering the range problem of mobile EVs. To collect real-time information, heterogeneous wireless network is suggested by gathering cellular networks with VANETs. Chapter 1 and Chapter 2 respectively introduce the impacts of EVs on the smart grid architecture and the EV charging-discharging strategy classifications, design issues, and challenges. In Chapter 3, the issue of coordinated EV charging strategy related to VANET-enhanced smart grid is elaborated, which improves the overall energy utilization keeping away from overload. Also, the range issue of EV is discussed along with reducing travel cost. Here, V2V charging is achievable because of the directional charges of EVs. Therefore, the heavy power EV charging demands can be removed from the grid due to overloading. This chapter also includes performance evaluations using simulation setup. Chapter 4 discusses a semi-distributed online coordinated V2V fast charging strategy based on price control to emphasize the charging overload problem. In the strategy, EVs having sufficient energy can charge demanding EVs to balance the supply and demand in the smart grid. It also includes the problem formulation and system model. In the end, Chapter 5 includes concluding remarks and future directions. Readers interested in next-generation online charging and discharging for mobile EVs will find much useful information in this brief book.
Thank you, Haluk, for a wonderful book review. It's now time to grab a cup of coffee and listen to our interview.
I am Professor Ansar Yasar from Transportation Research Institute, IMOP, Hasselt University, Belgium. We are today with a young and dynamic professor, Professor Brendan Morris. Brendan Morris is an assistant professor in electrical and computer engineering at the University of Nevada, Las Vegas. He received his BS degree from the University of California, Berkeley in 2002 and his PhD degree from University of California, San Diego in 2010. His dissertation research on understanding activity from trajectory patterns was awarded the IEEE ITSS Best Dissertation Award in 2010. Dr. Morris' research focuses on computationally efficient algorithms for real-time processing. His work on activity understanding and enhanced situational awareness combines computer vision, pattern recognition, and machine learning. Furthermore, Professor Morris is being accompanied by his former PhD student, Dr. Mohammad Shirazi. Mohammad Shirazi has recently joined Cleveland State University as a visiting assistant professor. He got his master's in computer engineering from Sharif University of Technology, Tehran in Iran, and completed his PhD from University of Nevada, Las Vegas under supervision of Dr. Brendan Morris. His PhD dissertation focused specifically on vision-based analysis of behavior and safety at intersections, and he won the second prize of the IEEE ITSS Best Dissertation Award in 2016. Professor Morris, together with Dr. Shirazi, recently published an article entitled Vision-Based Turning Movement Monitoring, Count, Speed, and Waiting Time Estimation at the IEEE Intelligent Transportation Systems magazine. So, without any further delays, we will go ahead with our interview. Hello, Professor Morris. Thank you very much for joining us today. Can you please introduce yourself and your team to our audience?
Hi, Ansar. Thank you very much for having me for this interview. I'm really happy to be here. And you did a great introduction. I'm a professor in electrical and computer engineering at UNLV in Las Vegas, and I'm here with my former PhD student, Mohammad Shirazi.
Professor, congratulations on that publication. Can you please talk a little bit about it? You were trying to make numerical estimations of speed and waiting time at intersections. based on vision. Is that correct?
Yeah, so basically here in Las Vegas, like many other metropolitan areas, we have a need for arterial traffic data. And unfortunately, we don't have that currently. So what we wanted to do was provide a way to measure turning movement counts, which are the number of cars that go straight or turn right or left at an intersection. And we wanted to do this in an automated fashion, since usually what happens is our transportation management companies will have to hire people to sit on the corner of an intersection and manually observe. So what this means is that they can really only pay to have people sit out there for a few hours on a single day. So instead of that one day during the peak hours, we thought, why can't we just use a camera system to automatically collect this information all the time? So we wanted to give exactly that, the turning movement counts all the time in 15-minute increments. And in addition, we said, well, if we got the vision system working, we can also get the speed of vehicles, how long they're waiting at intersections, also look at pedestrian counts, and do queue analysis, etc.
Thank you so much, Dr. Morris. My next question is for Dr. Shirazi. Dr. Shirazi, what were the main challenges for you observed for numerical estimations using video, and how you addressed them in your developed system?
Thanks for asking this important question. When we want to have the numerical estimation through the videos, we need to have something simple and fast. And we know that motion is a strong cue for detection in computer vision. It is very efficient and simple to detect vehicles using motion. We want to keep having this efficient way to detect vehicles, but the problem is that vehicles might lose motion at intersections due to many reasons. For example, they might wait behind the red signals or stop bars. This paper addressed this problem by taking some signatures of vehicles and compare them with new appeared vehicles to check and see they belong to the same vehicle or not. If it is, we can simply connect it.
So my next related question would be, what were some important contributions and findings in your work?
Yeah, this is actually a very interesting question. When we started doing our experiments, we started getting the turning movement counts for 15 minutes intervals for 5 days a week. And besides that, we also got the information about the waiting times and also the turning speed, the speed profile of turning rights, going straights, and turning lefts. And one of the important findings that we got is that the turning right basically gave us the different profile. For example, for the turning speed, they are taken more slowly for turning right, or when you are waiting, for example, based on the waiting time, their distribution show you that their waiting time is less than other turnings. Which makes sense, because when you take a turning right, you usually do not always take a permission from the signal. Even if it is on the red light, you can still take a right turn, so your waiting time should be less. And another good finding or important finding is that when you are taking the right turn, you usually take a look at those opposing flows, because we had a system that gives us this information, waiting time, turning movement count, and speed. We try to find the correlations and see how this waiting time can be affected by different flows. And we actually got that when you are usually turning to the right, you basically observe different flows, and those flows that come to the same zone areas, they affect your waiting time. So you wait until they all pass, and after that you take a right turn.
Thank you so much for your explanation. Switching back to you, Professor Morris, I think your work may have implications on origin-destination matrix building, a classical tool for our colleagues in traffic modeling and simulation. Is that correct?
Yeah, certainly that's one of the things that we thought about when we started this project. Is we were looking to get data for traffic engineers, and some of that could be origin destination matrix building. So we would actually have the counts that could be used to initialize traffic models. But also, we are getting this arterial data in real time. So we could have actually more operational management measures. So this is like knowing what the speeds are and the waiting times of the intersections to figure out if there was a backup, well, maybe we need to change the signal timing. So again, I mean, one of the main things that we really wanted to do was to provide the data so that it could be used in a more efficient manner later on, whether for modeling, whether for planning, or whether for operations.
Okay, thank you. So in the past, you have done some work around the topic of lane change intention prediction for driver's assistance. Do you think that you can use your recent work to extend upon what you have done in the past?
Yeah, this work you're talking about for lane change intent prediction, this was actually quite a bit different in the sense that it was designed for driver assistance. So we were looking at systems inside a car, and we're trying to give the car the ability to understand the driver's intentions. And so in that work, what we looked at is trying to predict a lane change 2 to 3 seconds before you actually made it. And the idea there is that if you knew, or the car, I should say, knew that you wanted to make a lane change, then maybe it could do things like turn on the turn signal for you. So it's not directly comparable to this work, which is a lot more infrastructure based, but maybe in a more general sense, the same way that a car should know about the driver, we can think of an intersection needing to know about the traffic participants at the intersection. And one way to think about that is now the intersection could have an idea and predict what each and every car or pedestrian is going to do. How long are they going to wait? Or is that car going to make a right-hand turn or a left-hand turn at the intersection? So I think, this probably does have implications for the next generation of connected vehicles and this idea of the smart city where you have infrastructure talking to people, talking to vehicles, and this exchange of information back and forth. So I think ultimately this prediction of an intent is important for future systems and safety in particular.
Very well. Thank you. Now we will have to take a short break. We will be back in a few seconds. Stay connected.
The interview is very interesting so far. Dear listeners, if you would like to collaborate or volunteer for our ITS podcast, or you have some interesting information to share, please get in touch with us at ITSPodcast@gmail.com.
Okay, welcome back. We are back with Professor Morris and Dr. Shirazi. Professor Morris, we have learned that you are part of the Real-Time Intelligent Systems Lab at the University of Nevada, Las Vegas. The lab performs research in computationally efficient intelligent systems, and it combines computer vision, machine learning, and pattern recognition to develop real solutions. Can you please tell our listeners about the type of solutions that your lab worked on, and what are your future research plans?
Thanks for the opportunity to talk about my lab. Appreciate that. Yeah, the group is a computer vision group that works a lot in ITS areas, and so we are very interested in being able to provide systems that do measurements in real time. And work that happened in the past was UC San Diego and UC Riverside was looking at estimating the emissions from vehicles using cameras. We've also done work with Volkswagen doing the driver intention prediction for driver assistance systems. And more recently, we've been looking with Nevada's Department of Transportation at pedestrian safety and ensuring that we don't have as many pedestrian deaths on the roads here. Further work that we're going towards is looking more at self-driving cars and really considering behavior prediction and accurate behavior prediction to enable these self-driving cars to navigate in an uncertain world where you have human drivers. And more generally, and from a computer vision standpoint, we're working on fine-grained classification problems. So being able to not just detect a vehicle, but be able to say what the make and the model of it is, as well as some new ideas in activity analysis, thinking about the quality of an activity.
Wonderful. Thank you so much. So, Dr. Shirazi, I have a slightly different question for you that will be quite interesting for our student members or early stage researchers. So, how do you feel after your transition from University of Nevada, Las Vegas as a graduate student to a faculty member at Cleveland State University? What are the research topics that you are currently working on?
Thanks for asking these interesting questions. The feeling is amazing, but it's quite different. I should confess that it's different from the time that you are a graduate student. Because when you are the graduate student, you are basically active in research and writing papers, and you have a person as an advisor, so you can also refer to him. But when you are start working as a faculty member, then you need to take the whole responsibility. So my suggestion for the young researchers or earlier stage researchers, graduate student, is to try to be more independent people or persons, because after joining the university, they need to take the whole responsibility in the research missions and also educational missions in both areas. And back to the research question about the topic. So I have been working on the area of detection and tracking of the road users, including vehicles and pedestrians. So my goal was to monitor the activities and the behaviors, and also provide some safety measurements. But the part of my future plan is to basically get the informations from the system and also use this information with the autonomous vehicle or advanced driver assistance system. So at the first level, I'm interested to develop the efficient systems which basically provide you this tracking information, and also some other model or some other tools, like for example the tool that can, for example, detect the traffic phase signal from the infrastructure point of view, not from the vehicle point of view, and provide this secondary data or useful data to the autonomous vehicles like intelligent vehicles or advanced driver assistance system, because we know that advanced driver assistance systems also have the traffic light detection and recognition. So this will be a great help for improving the total safety, because we know that safety has a different elements. It's a vehicle side, the infrastructure side, the pedestrian side, and we need to have a proper communication between these elements.
Okay, wonderful. Professor Morris, in the year 2016, you have been elected as the Vice President ITSS Members Activities. I wanted to ask you about your experience in this role. What new measures did you put into place in order to boost the number of members joining the team and their involvement in the society?
Thank you. I'm really honored to be the Vice President for Member Activities for the Society. I think the ITS Society is a great community and something that I'm really happy to be involved with and to help grow. Some of the things that we're trying to do is to increase student activities, and what we've set up is through our main flagship conferences. We have the ITSC conference and the IV symposium. We have student activities which are designed to get students to interact with one another and to become more involved in the community. We also have some new initiatives to start new educational modules on the website. So this is a really exciting new area for us to train and learn more about the upcoming areas in ITS. And finally, we're working on increasing chapters. And these local chapters are smaller ITS society entities which help a local area, such as those in Japan or in Spain or in Tunisia, interact with other researchers, other industry people, all working in ITS in a smaller scale to promote collaboration.
All right, Professor Morris and Dr. Shirazi, thank you very much for your kind participation and interesting comments. Do you have any advice for our valued ITSS members and podcast listeners?
Thank you so much to you and anyone who helped us to set up this interview. I hope that all the ITS members who listen to this podcast enjoy this conversation and they got useful information out of it.
Yeah, I'd like to thank everything Dr. Shirazi said, and I really appreciate the chance to speak with you and to the community and talk a little bit about our work. I guess to give some advice for our listeners, I hope that everybody continues to follow their passions and work together to improve ITS research and make the transportation world a better place. Thank you so much.
Thank you so much, Dr. Brandon, Dr. Shirazi. And I think I would like to also give a small advice to our listeners is that keep on listening to the ITS podcast and keep on supporting the community because only because of your support we can make it even better every day. And that was all. And this is Professor Ansar Yasar signing off. Goodbye.
Thank you, Professor Morris, Dr. Shirazi, and Professor Yasar. I hope you enjoyed today's episode. Wish you the very best for the upcoming year. We will appreciate if you share your comments and ideas with us. This podcast is sponsored by IEEE Intelligent Transportation Systems Society. This was Dr. Mayam Kavashkar from IEEE ITS Society. Please subscribe and share our podcast.